Anyway, I didn't ever finish the first chapter. A student was pointing that out, and I did know that. So let's finish this part, the third part of the first chapter, and then we'll do the assembly language chapter. So you got imports. If you have a function, imports are what the library functions you use. So you want to call something to draw something on the screen or pick up data from the network card or something, but those involve touching the hardware, and your user-land program is not authorized to do that. It has to call a library function, which goes to a Microsoft routine, ultimately in the kernel. Typically, you call a function which calls another function, which calls another function, but anyway, these are called imports. A code that you run that you've imported from somewhere else. And this is a big deal these days. We're all getting aware of the insecurity of this and the supply chain attacks. Everybody's code is using other people's code, which uses other people's code, until you're using stuff from God knows where. You don't know how out of date it is, you don't know what nation it came from, and actually, why do you trust it? So anyway, however, in Microsoft code, it's pretty much all written by Microsoft and by your hardware makers, so it doesn't have that kind of supply chain issue unless you're using languages like Python or Go or JavaScript and loading libraries from the internet, which load other libraries from the internet, and then you've got a problem with your software bill of materials. And what we're talking about here is local libraries on the Windows machine that mostly come from Microsoft. So when you connect to a library, you can have static linking, runtime linking, or dynamic linking. Static linking is what was used in Linux until recently. Now, it's switched to the Windows type system now, where you would just take all the code in the library and copy it into your executable. So if you have a program that uses networking, it would have a copy of the networking library. If you run another program that uses networking, it would just have a second copy of the networking library. So you'd have a lot of extra RAM being used, but it's of course nice and sanitary. And runtime linking is common in malware. This is where you connect to libraries when you run them while you're running. So they don't even load them when you first load the program. When you call certain functions, then it connects to a library. And as we'll see, this is used by malware to connect to libraries. Not very common in running code, in normal code. The main method is dynamic linking. These are why they call them DLLs, dynamic link libraries. This is the main thing used by Windows. It is designed to make your operating system fast and to use the minimum amount of RAM, and therefore it's efficient. It's also dangerous and unsanitary, and we're going to exploit it. So anyway, when you launch your program, it looks to see if the libraries have already been loaded by other programs, and if they're common Windows libraries, they probably have, and then it just connects to that copy of the library in memory that's already there. It doesn't have to load anything. That means it's sharing that library with other executables, which is sort of unsanitary. And by the way, this is why you always get the missing DLL messages. Every version of Windows from Windows 98 till now has had this problem. You load something that used to work and it says there's a missing DLL. This is because Microsoft hasn't solved the problem of linking, which Linux solved in like the 60s, where when you delete a program, it removes the program, and then it asks you a question, shall I remove the DLLs? And you're like, how do I know whether to remove the DLLs? You guess. If you remove the DLLs, then it's going to break other programs, and Microsoft hasn't kept track of that. Linux did. Linux has a thing called the link number on a file, so it knows how many different programs are using this file, and it doesn't delete it until the link number falls to 0. Microsoft did not get the memo. Anyway, so that's why you have this persistent problem of missing DLLs in the Windows world. So the PE header lists all the libraries and functions. They'll be loaded. When you load the program, it then connects to those libraries, either loading them into memory or just connecting to the running copy that's in there, and you can see them. And the names are usually pretty descriptive, like download to file means this program downloads something from a URL, and so on. The dependency walker, I mentioned before, is a program intended to solve DLL hell, where your program keeps trying to find a library and the DLL is not there. So services.exe is here. It uses all these DLLs. This is pretty common. Normal programs use a lot of libraries. Malware is often simple and uses only a few. Here's a fake copy of services that uses almost nothing, just a couple of DLLs. One of the many ways you could tell it's not a genuine program. By the way, there's two other things I should mention as general information. First thing is the competition team is forming. Email Liz. You should probably get an answer back in a week or so. I highly recommend this. It's very good for the advanced students. If you're struggling and want to do just the bare minimum to pass the class, then this is not appropriate. But if you're beyond getting an A in the class, you want to move forward and really impress employers and really get skills in high demand, this is what you do. This takes you into realistic situations where you go through the real steps of being a red or blue team professional and interacting with management and writing reports and all the good stuff you should do. So these are very good for you. And the students that we had before that do the competitions on the teams sail into great high-paying jobs. And by the way, the other thing I wanted to mention, I don't know if I've mentioned it here, is there's a class here where you can view training videos. And I've had at least one person is recommending some of these to me. I appreciate it. There's whole categories here. You can get a bunch of extra credit points by viewing these videos and writing little summaries of them. And in this class, I highly recommend this ZeefCon one. I've been listening to these, and these are very interesting. And here it talks about how you detect beacons from malware beaconing home. Here it talks about other techniques. There's one the most relevant to us right now is this one here, the signature. Your file has a digital signature, but the Microsoft digital signature does not sign all the sections of the portable executable. So you can, in fact, take a legitimate signed Windows executable and you can add extra data to the end in an additional section, and it will not make the signature invalid. And there's malware that uses built-in Windows programs to run it, referring to it as if it was a Windows compiled HTML file with a programming in it, and it finds the programming at the end, it executes it, and it passes all the Microsoft signature checks. And when he found this malware doing it, he thought he was going to get a CVE, and he said, no, Microsoft has known this since 2012. And they fixed it in 2013, but they said the fix might break a bunch of legacy programs, so it's not on by default. And there's not even an easy way to turn it on. You have to go into registry edit and turn it on. And he said, in years they've been talking to people, they never found anybody that has this turned on. And everybody should have it turned on. Then it actually checks the signature. There's a lot of interesting stuff here. This is actually relevant to the stuff in this class. So anyway, check out the ZeefCon videos. Another thing you might check out if you want to, and you'll find this on my homepage. It's good for any of my classes, this V1 project, where you can get extra credit by watching training videos. And of course, if you find another source of training videos, that's fine. And if you let me know, I'll add it to the list. These are just collections of videos from conferences, but you learn a lot that way. And I think we all got to get used to viewing videos and doing things virtually. I'm sort of getting fed up with traveling to things. Anyway, so, all right. So anyway, in Dependency Walker, you can see the imports and the exports. So imports are functions that this program will use, and if it's a Microsoft library like msvcrt.dil, it's probably using really low-level functions with these funny names with like underscores in front of them. They're really low-level functions, not generally intended for an average user program to use. The exports are here, functions it offers, and MSCVCRT does export those, exports all these functions. Those are exports that will go into here. So anyway, imports are the libraries you use, exports are the functions you offer other people. So normal executable has only one export called main or start. You only enter it one place and run it. It does not offer any other service. All right, so here's some common DILs. Kernel 32. Remember the fundamental rule in Microsoft, everything is always named the opposite of what it is. Kernel 32 is not the kernel. It is the user land gateway into the kernel. The kernel is actually called NTOS kernel. AdVapi is advanced API. Here's user 32 that gives user interface components like buttons and scroll bars. Here's GDI for graphics. These are common DILs that you'll see called.
So is the 32 just indicative of when it was written, a 32-bit machine?
Exactly. These are written for 32-bit Windows, and they continue to be used even in 64-bit Windows. Again, just to keep you confused at all times. So, and so NTDIL, this is the interface to the Windows kernel. So now kernel 32 has functionality it's also used, but NTDIL is the main thing you call, but okay, let's talk about this. The kernel is actually NTOS kernel, and we're going to debug it in this class with kernel debuggers and stuff. You'll get pretty familiar with it. But you never call that directly. That's in usual. And what you do is you import kernel 32 and you call routines here. And they have friendly readable names, and that's what a legitimate program is supposed to do, is import kernel 32 and use it. Now what kernel 32 actually does is it calls NTDIL functions. But NTDIL functions are really for Microsoft internal use only. They are undocumented. And you're not supposed to call them directly. This is called the low-level API. Now, the fact is, even though Microsoft has tried to hide some secret functions, you can't hide anything. When we get to the debugger, you will see that you can use WinDebug and you can see all the code in Windows. You can totally find out what everything is doing. They can't hide anything from you once you know a little reverse engineering and debugging. So people have figured out these functions, and they're the native API. And malware often calls it directly because the antiviruses often try to catch the calls up here, where you're usually going to use them. So you can skate right past that and call the native API here and have any very powerful functions. In fact, there are things you can do that you can't do the other way. So like hiding functionality, manipulating processes, this is something you'll see. Here's networking DIL. This is called Windows sockets, referring to the original UC Berkeley invention of the internet. They invented these things called sockets. They made the basic socket library, the Berkeley Common Sockets for Unix that define TCP and port numbers and the handshake and all that jazz. And the Windows version of it is here. And WinINet is the high-level one. Again, this is the low-level thing where you would make your own handshake, handling packets one by one. That's called raw sockets, and you're not allowed to do it on any modern versions of Windows. What you're supposed to do is use WinINet that has a high-level function like download a file from a URL, which will then call WinSock functions and do the handshake for TCP and the error correction and all the little things that you don't normally want to do manually. So DIL's export function, EXE's import functions. And both of these are in the PE header. You have to know both your exports and your imports in order to load a program and run it. So here's notepad.exe in PE view, and you can see the import address table. It imports a lot of functions. There's a scroll bar, and you see these are the high-level functions you'd expect to use, like advanced API.dil, and they have these nice friendly names like reg set value. Very often Microsoft functions end in like EX or W or A. X means extended because it's an extended version of some earlier version, and often there's XX or XXX. And W means it uses wide words, wide characters, which are 16-bit characters. And A means it uses ASCII characters. And so most everything in Windows uses 16-bit characters, but there are some things that actually do use ASCII. All right, and here's advanced API.dil showing an enormous number of functions. This is just part of the A's up to the ADs. There's a scroll bar there. This is really a lot of functions. So there's a ton of API calls inside Windows, and this is all your program is doing is calling Windows APIs to do this and that, to open Windows and read the user input and do everything it does. Here's iTunes setup. See, here's the raw structure. Everything starts with this program cannot be run in DOS mode. This is the useless MS-DOS appendix. Here's the real portable executable header coming. And again, you'll see it here. Every executable has to have this stuff. It has to start with MZ, and then it has to have a PE header here for the real modern stuff. So here's a keylogger. For example, if you want to make a keylogger that'll read key presses, there are various ways to do it. One way to do it is use this function, set Windows hook EX. You can make hooks in Windows, and those will interrupt processing. When someone makes an API call, it will say, wait, there's a hook. Before you run that, go run this. Now, this is important because you might have like a fancy keyboard, like a wireless keyboard, and then you'll say, when you're reading the keyboard, don't do that. Go over to my special device driver and read that. Things like that. So there's many ways in Windows to add extra code that runs before other things. And if you have antivirus, of course, you double click on a file and it says, wait, before you open that file, call my antivirus and I'll check that file. That sort of thing. Microsoft is full of ways to interrupt code and add extra code, and of course all those are very handy for malware, to just add extra code. So anyway, it uses register hotkey to define a special keystroke to harvest the data and so on. It'll be listening to keystrokes. And then there's packed programs. So your packed program will have almost nothing. It's a couple libraries, almost no functions, because all you're seeing is the unpacker. And all it does is allocate some memory and then unpack the thing into memory. So it doesn't really use very much of the API at all. All right, so the text section is, of course, not readable text. It is the machine language instructions that are executable. The readable data is down here in resource strings and things like that. Might be in these others. Our data is imports and exports. That's the import table and the export table. And here's global data. And there may be other sections too, like relocation, to relocate it in memory, and many others. So PE view lets you see the structure of the file, all the sections, and how big they are, and it interprets the data, makes it easy to see. And you have a time date stamp. Every time something is compiled, there's a time date stamp, but it's not verified anywhere. So you can just put anything you want, like all Delphi programs will just show the same date, and you can in principle overwrite it, but a lot of people do in fact not prevent that. And so you can see what language it was written in, and you can see what time of day it was written in, and Kaspersky and other threat intelligence workers use this to guess what country the malware was written in. Then you've got virtual size and size of raw data. The size of raw data is the amount of disk space used to store this. And when you load a program, it takes the sections and it puts them in memory, just copying them into memory, but it makes gaps between them. So the memory image is a little bigger than what was on the disk. And so that's why you have a virtual size, is the size in RAM, because it rounds things off to the nearest 1,000 in hexadecimal. So packed executables will show virtual size much larger than the size of raw data. Normally it's only a little bit bigger, but if it's packed, it's going to unzip and put it in RAM, and so the RAM image will actually be much bigger. So here's a not packed program. The virtual size is A6HC, and the size of raw data is A800. So you see they're pretty much the same. And a packed program, the size of raw data might be 0, because it's all packed in another section, and the unpacked will be big. So this is just not, there's nothing stored in that section in the file on the disk, but there's a resource section that has some data which will be unzipped, or some other section like these sections down here have some data that will be unzipped and put in there. So when it's expanded into memory, it will be bigger. All right, so Resource Hacker, by the way, is another hacking tool used for people to play games. You can just change things. You can view the strings, icons, and menus, so you can take a game and change the pictures to be a different picture and things like that. Resource Hacker will just let you browse through the structure down here, and you'll find the colors that the game is using and images and other things like that in there. It's a simple way to change some of the contents of a executable. Of course, it wouldn't be a signed executable if you're going to get away with that, but many things are not signed, like games and stuff. So let's take a look at 1C, Cahoots. All right, there we go. All right. There we are, 1C. Maybe that's everybody. All right. All right, so what technique makes an executable large? static linking, because it puts an extra copy of the library in with the executable. And DG, you could join the Kahoot and answer there. You don't need to answer in chat. Anyway, all right. So what technique is the most common for normal executable Windows files? All right, that's dynamic linking. That's what the DIL files are for. That's the general way that Microsoft prefers to do things, and Linux does the same thing now. All right, so which library is required for malware that uses FTP? Okay, that's a little harsh, but you normally use WinINet. You'd be very unlikely to use WSOC. Then you would have to handle the handshake and every packet one by one, and that's pretty crazy. In principle, you could, but I don't know anybody that would do that. You use WinINet, the high-level library, for that kind of transaction. All right, what library is required to show boxes and buttons? Yep, that's user 32, user interface components like that. All right, and what library is not normally used by EXEs? Yep, NTDIL, that's the native API. Not normally what you use. What email should I provide for the scholarship? Yeah, probably use that one, I guess, if they need an email for me. Yeah. All right. Good. And so let's see who won. All right. I think I know who that is. We'll figure out, I'm not sure. All right. So, good. Let me stop this recording and switch topics.